Swayam Prabha. Digital India. Educated India.
Dear students, today I will teach you the biosensor in some different way. You see, today's topic is the biosensor for safety and security. So some other applications. So now we are very close to completions of this syllabus of our subject. That's why today I plan to show you the different applications, I mean some other applications, not only always the disease, some other applications for biosensor. Let's see. So main things I will discuss today, our main concept that I will cover is the safety and the security based on the biosensing applications. So where we can apply the biosensing applications, not only the disease diagnosis, there is so many other applications. Those topics let's cover it. See, lots of details I already have written in my slides, but just I want to summarize and I want to show you some a basic concept, a story where we can apply the biosensor. So it can be the security and the bioterrorism applications. So you may ask, sir, what is this? Actually, we can develop some biosensor device that can be equally useful for chemical warfare, toxic agents, and therefore the bioterrorism prevention. See, the biosensing device that can be real time, that can be useful for toxicants such as microbes, pathogens, different toxins. Also, especially in the war field, we may need this kind of sensor that can help you for prevention, for like the nervous gases, different kind of nervous gas such as botulinum toxin, or maybe different toxins such as Escherichia coli. Those agents we can detect. So the main things that I think I wrote this story, you please go through this story, that it can be useful different kind of the toxins that we may want to detect during the security and the bioterrorism purpose. See, the detections of the explosives is another things, and especially for the biomolecules is an important part for the security, that you can detect the different kind of explosives. Okay, so the biosensor for the security and bioterrorism, now you understand, right? So why we need this is really important. Let's show you a overview. Like electrochemical biosensor, it can be used for chemical warfare agents. You can see this full story, like chemical warfare agents, then I mean the different kind of nerve gases, blood agent like hydrogen cyanide, cyanogen chloride. So we really need kind of some protections once for to know if there is this kind of agents presence or not. That we definitely we should have the information. For that we can use some sensing device. If you see this this writer, see this one, you can see the chemical warfare agents are highly toxic. Even the synthetic chemicals that can be dispersed in the environment as the gas, as the liquid, or the aerosol. So it can be very much, you can say, means dangerous in the war fields also. So we should have the some biosensing device. See, I already taught you the main basic mechanism. Today I just wanted to show you the basic analyte. Like this is the scope. I am telling you this is the scope. Here you can apply the biosensor technology, right? How we can develop, now you can ask how we can develop this detections, like all the toxic agent, how we can detect. I mean that story, like just a simple sensor, and Like you can use some very specific nanoparticle that can be useful for the that's very specific toxin detections, that, or maybe some specific bioreceptor. It can be aptamer, it can be DNA, it can be RNA, something like this. So that story you know, but you should know the area of your interest. So this is the one of the basic area of the interest for the biosensor. So let's show you the story here. So first story, the types of the agent. So you should know like different category of these toxins present, and they are very much harmful, and based on their toxicity we can categorize them A, B, like this way. See, we categorize first the category A toxins. They are high mortality rate they have, and the risk of, they're highly risky, high priority agents that pose the risk of national security. So we should have focused this kind of toxin agent for biosensor development, that I am going to tell you here. Kind of like anthrax, smallpox, this kind of the type category A toxins we should detect. Maybe you can develop some biosensors. All the concept is same. So after few class also, after this class, as we are very close to the completion of this course, when I will take one more tutorial there, I may ask you to design kind of smallpox detections, right? But you know already. But just today I am just showing you like anthrax, smallpox, this kind of the category A agents that we can detect based on our biosensing technology. Clear? Now come the another toxin that I told you, like botulinum toxins and the bubonic plague. So this kind of toxins also you can try to develop a sensing device. Okay, now another some example like viral, some kind of agents like hemorrhagic fever, that also can be detected. And so there is lots of example of the category A. Now let's come the category B. So category B, as they are moderately easy to disseminate and have the low mortality rate, but still you should have the some informations, but you can detect them if it is present. So they are the kind of category B. Okay, so they are moderately and they are easy to they can easily disseminate. It can spread all over among ourselves, and it can be sometimes dangerous also. So for that also you can focus your biosensing device. So your biosensing device you can develop here. This is the another scope you have. Now I am going to tell you some marine toxins. I think from the name you can understand, right? Because our many areas, not all over the world, we are highly dependent on the seafood. We like seafoods also. So eating the seafood may result in the different kind of foodborne illness. So there are also some scope, right? So now see, there is vast area you can think about to development the sensing device. One is the marine toxin. What kind of marine toxin? The seafood may, they look the good, they smell good, taste good, they are very delicious, you may feel, but they may be contaminant, right? So therefore the several types of marine toxins and what kind of the the problem can cause in the health, that also you may think. So here I just mentioned some different kind of the some name you may think about more in this area. So some viruses, bacteria, fungi, protozoa. So this kind of some toxin and some analyte you can detect for the marine toxins. So I mentioned this sexy toxins or tetrodotoxins. So this kind of toxin can be considered the potential chemical warfare agents. So those you can detect or try to develop some sensor. So that's done for the agents or different kind of warfare agents or different kind of marine toxin agents that you can focus. Okay, that's one part finished today. Now let's come to the another area. So today I just mainly want to focus on different areas where you can focus your biosensor technology, not only for the disease mainly we are very much familiar, right? Today again you can see this slide, this slide. I am going to show you again something not as usual, but something you should think. Development biosensing device based on like soil detection, that is called soil on a chip. See, our soil, we are, I mean, your plantations, that's you are doing on soil, that can be contaminant, right? We are using fertilizer, we are using pesticide, many chemicals we are using, but those chemicals can contaminate your soil, and your drinking water also can be contaminated from the soil, because during the rain, so this means rainwater can go through the soil, different kind of pesticides, different kind of all the chemicals can dissolve and to come to the ponds, river, and we are drinking those waters, right? So that's why detection those analyte in the soil or in the drinking water, that is equally important to make ourselves healthy, right? So whatever we are drinking, we are taking food, where we are cultivating, so those places are safe for us or not, right? This is a good scope for development of sensing device. That's why I am saying here soil on a chip, means we can detect the soil health. This is indirectly we are actually means we are checking our also health conditions, because we are cultivating our foods, everything on soil, and if soil health good, then you also will get the better production from the soil, right? See, we can develop some chip, that means including the microfluidics. See, you can see the integrations of the microfluidics. There can be some, see here maybe you can inject some sample. What kind of sample you can inject? Maybe some extract from the soil, or maybe drinking water, that you can inject, or maybe you can extract from the plant, and then this all the things come, maybe there you can here maybe you can incorporate your sensor, your biosensor maybe here. Now let's detect your sample. How you will detect? Those techniques you already know. I will discuss a little bit. So I am saying that there is a scope for soil health determinations. It is equally important. See, nitrate. Why I am saying the nitrate always? Because nitrate fertilizers are very much important for plants. The nutrition the plants they are getting, main thing is the nitrate based fertilizers. But is it good if we apply large amount of the nitrate fertilizers, right? They can, means plants they are getting the nutrients from the fertilizer, but if they are too much, see, maybe it is not, I mean it is unused conditions, so those nitrate can come to your drinking water, it can contaminate your drinking water. Then there is a lots of health hazards, health problem happen because of this nitrate. Even pesticide, we are using different pesticide to get the very good productions for your fertilizer, for your your crops productions, but these fertilizers kind of the chemicals, different chemicals, right? So you have to use in the proper ratio, not is too much level. So we have to understand the level of the fertilizers, level of the pesticides inside the soil, so that they should not contaminate in the drinking water, or it should not enter in anyway, indirectly it's come to our inside body. They can, then we may face different issues, different health problems. So let's show you one soil on a chip, very basic concept right now, like fertilizer and the pesticide, right? So then what our concept to boost our agriculture productions? We are using, like we are supplying different nutrients, different fertilizers. So sometimes we are thinking, if little amount when we are adding to the soil, if we are getting very good productions, let's add more, then we will get the more production, right? That's we are thinking. But no, there can be some problem, like this kind of nitrate, organophosphate, they can affect our whole global nitrogen cycle. They can kill the livestock that I told you, it can come to the rivers, and also human also health hazards possible, like different kind of cancer, diabetes, thyroid problem, neurological disorder, it may happen because of this. You are thinking that let's use more and more nitrate fertilizers, we may get the better productions. So we have to stop. How we can stop them? No, you should not. We have to, give some awareness to the farmer. This kind of awareness you have to create. What awareness? Means you can develop a device, then like maybe you may have one nitrate, another is the pesticide or different kind of other analyte you can that you want to detect, and those that can have the human health hazards, those you want to detect from the soil, right? So all the nitrate, phosphate, different pesticides, so different channel we can make a sensor chip, lab on a chip, that we are saying the soil on a chip. Now let's collect your soil sample. Okay, so you should know the information means how you have to collect the soil sample. There is a story on how to collect the soil sample. You have to go inside the productions area, near the field. You have to go a certain depth of the field and collect some soil, and then you can dissolve this soil and make some extractions, and those extracted sample you can put here on a chip. Then detect here nitrate 1, or maybe here some phosphate or some others, all analyte. Like you may need to detect also the arsenic, right? There is arsenic 3+, arsenic 5+, you may need to detect, because that is also very bad contaminant for the soil. Why? Because from the soil may be this is not coming from the fertilizer, that I am showing that your soil may have the arsenic also, because in our India many places arsenic contamination is really very badly affected. So you may need to detect this arsenic also. So you can make a soil on a chip, that's why like this is kind of multiplex soil on a chip. So what will help this one, multiplex soil on a chip? It can help to detect at the same time all this analyte together, so that you can detect. Let's show you some one soil on a chip, some basic biosensing mechanism. See, as I mentioned that you can fabricate first your biosensor chip. Biosensor, this is the working area, right? This is working electrode, means you are making a, you can see here, this is some chip here, a working electrode, different counter electrode, and this is just kind of, you can injecting the sample, and then it will pass through the working area, and your working electrode may contain this fabrication steps you have to follow. This is just for example, you know the basic concept that I will taught you. They are using like P dot or graphene oxide kind of some fabrication on the surface. On that surface they immobilize a enzyme for nitrate detection. This is nitrate, this is the reductase one enzyme. So this reductase enzyme will help specifically to detect the nitrate. Okay, so this is, although you may think the enzymatic reaction, this is enzymatic biosensor, enzymatic reaction for biosensor development. What biosensor? This is for nitrate detection. So how, means just like as I told you, glucose oxidase case, it can oxidize the glucose and selectively you can detect the glucose, something like this. Now here we are detecting the nitrate based on this nitrate reductase enzyme. And the very important thing is that this enzyme is very specific. Specifically you can detect the nitrate. Maybe your soil sample may have so many other contaminant. See, as I told you that like our real blood samples, it may contain so many interference species. At the same time, your soil sample also may contain so many interference species. Not only nitrate, it may contain like others, ion, phosphate. They may interfere your sensing strategy, sensitivity, right? So your specificity can be harmful. So your detection scheme should be such a way so that it should detect only the nitrate, not other anion. So you have to check interference effect in the soil samples also, as like I taught you for the serum sample. right? Different interference species present. So what the interference species can be in the soil? So in this case, chloride, right? It may contain different kind of chloride ion, like sodium ion, like potassium ion, calcium ion, and phosphate, sulfate. So these all kinds of different kind of ion can be there. That's why while you will check for the soil on a chip kind of sensor, and you are going to develop this kind of sensor, so you will be very much careful about the interference effect inside the soil sample. Okay, so this is just a concept for soil on a chip that you can develop for the like a soil health monitoring. Just think, I am saying this one for on-spot detection, maybe you have to think. This kind of device definitely you can use on spot, but this sensor made by the enzyme. You may think some non-enzymatic now. This is another scope, non-enzymatic soil detection, soil sensor development. Right. This is another scope. Like this, you can plan. Also, this kind of sensor you have to apply on spot. So you should have the proper information like how you can make your soil sample. That soil sample preparation is one of the main job for this soil on a chip. You have to provide this information to the farmer. So this is kind of the awareness you are creating for the farmer, so that before using too much fertilizer on soil, they may test the soil and they can check if there is enough nitrate already present, then no need to add the more and more nitrate fertilizer, something like this. So as for the basic all the things, now I want to conclude here. Let's summarize one by one. See, today I just taught you different applications for the biosensor, not for the health, some other application, right? So first is the bioterrorism, or for like in the warfare some different toxins, right? Different toxin detection. Let's summarize. So why it is really needed toxin detections? Because like different kind of terrorism, like different kind of terrorist attack, different cases. So you already heard about the bioterrorism, right? So it is very much dangerous. Different kind of different kind of cyanide gas, they also can affect our like whole population. So that's why this kind of development also can help our security, our national security, make our national security more stronger. Okay, so that you have to think how we can develop the different kind of sensor that can help to detect different kind of this kind of the bioterrorism. Means in this bioterrorism cases, that all the toxin names I already told you. You have sometimes like viruses also can be spread all over the populations. During the terrorism attack, the virus also can affect. Like you may think that COVID also can be spread easily, or sometime like it can affect the whole population. So you should have the proper solutions. If suddenly outbreak there, how you can detect this kind of viruses, bacteria, protozoa. So those you have to think. Second, I just told you different kind of marine toxins, because you know the seafood we are highly dependent, we like the seafood, but this seafood also can be affected different kind of toxins. So those toxins maybe you can detect and you can think about before taking those food. Number 3, then I taught the soil on a chip. So why I said this application for the biosensor, because not only the direct your monitoring for your human health, indirectly also our soil also can affect on our body, right? There's so many problems may happen. As I told, this nitrate can affect like many ways, right? Different kind of like nerve systems can be affected. So those kind of nitrate, organophosphate chemicals may come to our human body from this soil, from this water. So we should have that means proper detections before drinking. Maybe you can have the proper information, should I drink, or before cultivations on your field area, maybe you should have the proper information, should I cultivate your crops there, I mean, do I need more fertilizers, more pesticides, something like this. Or if some large area is affecting because of the by some other some farmers, they don't know, right, means unknowingly they may be actually contaminating our water system, that also should have the proper information. That's why determinations of soil health is really important. So this kind of concepts I just taught you today, just try to think, if you can develop this kind of device, it will be also equally important for the society. Okay, that's all for this today's lecture. Thank you very much.